Hello, this is Scholar Strife doing some math. Today in Algebra 1, we're going to be looking at graphing quadratic equations. Quadratic equations are always in this form. Y equals ax squared plus bx plus c. Well, that's its standard form anyways. They take on this U shape, and we call these U shapes parabolas. Parabolas. Now, they have a lowest or highest point, and that point is called the vertex. The axis of symmetry is the line that crosses, so let's draw another one really quick. Let's say we have a parabola up here. The axis of symmetry is a line that divides it into two symmetric parts, like the left side looking in a mirror and seeing the right side, or vice versa, right side, mirror, left side. So let's take a look on how to graph these. So we're going to look at the parent function. The parent function is what all quadratic equations look like. It's basically the equation that gave birth to all the other quadratics. So here we go. If we wanted to graph this, we're going to make a table. So we just choose some x values, -2, -1, 0, 1, 2. And then we're going to go ahead and plug them in. So if x equals -2, then I'll have y equals -2 quantity squared, which will be y equals +4. -2 times itself is two negatives, which makes it positive. Now if we do -1, y equals -1 squared, that'll give me +1. So I'll get 4, 1. If I plug in 0, 0 squared is 0. Plug in +1, I'll get 1. And then 4 if I plug in 2. So I start at 0, 0. Have 1, 1. I have -1, 1. I have 2, 4. And -2, 4. See how it's symmetrical? The left side looks like the right. The axis of symmetry in this case would be the line x equals 0, or the y-axis. Okay, the axis of symmetry once again is the line that cuts it in half. Alright, let's do another one. Y equals 3x squared. Okay, so we make a table, and they decided to use those numbers. So 3 times -4 squared is 3 times 16, which is 48. That's a huge number. 3 times -2 squared is 3 times 4, which is 12. Okay, this is 0. This is 12, and this is 48. So you notice how left side is just like the right. This is 12, that's 12. This is 48, that's 48. So I start at 0, 0, and I'm going to change these a little bit. Let's make this 3, this 9, 15, 21. So 112 would be here, -112, and then, oh wait, no, sorry. This is 212, 448, -2, 12, -4, 48. So this is just Same basic shape, just a U. Okay, now they want us to compare the graph with the parent function. So the parent function is this one. It looks pretty similar, but it goes up faster. So we call this a vertical stretch. Because it is going up faster. Let's take a look at some more graphs. So y equals negative 5x squared. So we're going to create a table. I'm going to use easy numbers, negative 2, negative 1, 0, 1, 2. Okay. Negative 5 times negative 2 squared is negative 5 times positive 4, which is negative 20. So the good thing about this is I have negative 20 here, so I can make this negative 20 as well. Okay, and then if I plug in negative 1, I'll get negative 5 times 1, which is negative 5. So this is negative 5. And then 0 is 0. So notice that our a value, if we go back, so the a value is this first number here in front of the x squared. Our a value is negative 5. Now what happens when your a value is negative is that you open downward. And we'll get to see by plotting our points here. Negative 220, 220, 1, negative 5. And then we got something like this. So if we compare it to the parent function, it's upside down. We call this a flip. And it's also vertically stretched because it's going down very quicker than normal. Okay, example 3. Let's take a look. Okay, negative 1/2 times negative 4 squared minus 2. So 1/2 of 16 minus 2 is 8 minus 2, which is 6. So luckily I can put a 6 here and a 6 there. Okay, now I'm going to try negative 2. Which is squared minus 2, which is 1/2 of 4 minus 2, which is 2 minus 2, which is 0. So these would be 0. And if I plug in 0 in the equation, I'll get 1/2 of 0, which is 0, minus 2, which is minus 2. So I'm going down here, make a dot, and okay, and then we're going to go to 0 for 1, or no, 0 for 2, sorry, and 4 for 6. So look at this graph is a bit wider. Wider graph means it vertically shrinks. So if you ever have to tell someone they're fat, I guess you could say they're vertically shrinking. Or I guess that's one way to look at it. They are vertically shrinked. Even though that's not how humans work. We have a specific height. We don't get taller if we're skinnier, and we don't get fatter if we don't get shorter if we're fat. Be interesting though. But if it's wide, it's a vertical shrink. And according to the parent function, this opens upward, so we're good. Checkpoint 2. Graph. Okay, here we go. So I'm making X and Y, making my table. And let's do -4, -2, 0, 2, 4. Now you can use -2, -1, 0, 1, 2. It doesn't matter. I know this will make it a little bit cleaner. So if I look at 1/4 of -4 squared minus 6, that'll be 1/4 of 16 minus 6, which is 4 minus 6, which is -2. If I plug in 0, I'll get 0 minus 6, which is -6. If I plug in -2, I'll get 1/4 of 4, which is 1, minus 6 is -5. So 0, comma, -6, 1, or 2, -5. And then 4, -2. So this is a wide one again. So we call it vertical shrink. If it's tall and skinny, it's a vertical stretch. If it's wide and short, it's vertical shrink. Hopefully this helped you out. Have a good day.